In this tutorial, you're going to learn how to solve a system in 3 variables. Let's illustrate with an example. So as I look at this system, what you're going to do is try to eliminate the same letter in all 3. So you can go x's, y's, or z's. I usually look for one that has at least a coefficient of a 1. Sometimes it's a little easier, so I'm going to choose to eliminate y. And to help keep track of everything, I'm going to number my equations as 1, 2, and 3 to help you see what I'm doing. And I am choosing to eliminate y in the first 2 equations. So to eliminate y, I'm going to just zoom in here a little bit. In the first 2, I'm going to multiply the top one by 3 and the bottom one by 2. This will create a pair of opposites. So I would get 12x plus 6y plus 9z equals 3. And the second one would become 4x minus 6y, there's those opposites, plus 10z equals negative 28. And now I stack and add. Y's being eliminated produces 16x plus 19z equals negative 25. Now what I'm going to do is I'm going to choose to eliminate the same letter in 2 other equations. So I'm going to pick 2 and 3 to eliminate y. So to do that, I can multiply the bottom one by, let's see, I would need it to be positive 3, so I'm going to multiply the bottom equation by negative 3. But I'll just recopy the original in number 2. So the bottom one would become negative 18x plus 3y minus 12z equals positive 3, and I will stack and add. So I'm going to get negative 16x, my y's are eliminated, minus 7z equals negative 11. Okay, so what I'm going to use or do now is create a new system out of these 2 equations. Because they both are only in 2 variables now, and I'm going to try to do elimination again. So I'm going to just stack these to look at them. So as I look at these, I see I actually already have a pair of opposites. It's not always going to work out that nicely. Sometimes you're going to have to multiply again to create the opposites, but beautifully I can stack and add here, which would be 12z equals negative 36. And look at this beautiful one-step equation. I would divide both sides by 12, and I get that z is equal to negative 3. So my solution here is going to be known as an ordered triple. Okay, it's in 3 variables, and z is negative 3. Now I need to go back and find x and y. And if I kind of just trace my steps backwards, if I go to this equation here, it's only in 2 variables. I could use either one. But if I substitute now into 16x plus 19z equals negative 25, and I take the negative 3 and plug this in, I have a equation in 1 variable. So if I add 57 to each side, that gives me 16x equals positive 32, divide by 16, and I know that x is 2. So I'm going to substitute that into my ordered triple. And now I need to figure out y. Well, y would be back in one of the original equations. So I'm just going to go with the very first one, the 4x, which I now know is 2, plus 2 times y, I don't know y, plus 3 times z, which was negative 3, is equal to 1. I'm going to clean this up. That's 8 plus 2y minus 9 equals 1. Combine my like terms, 2y minus 1 equals 1. Add 1 to both sides, I get 2y equals 2. Therefore, y is 1, and there is my ordered triple. Now you could certainly check this to make sure you didn't make any errors by plugging all 3 values into all 3 equations to make sure that it satisfies the equation. Okay, so we're going to illustrate with just another example here. And I'm going to choose again to number my equations to help me keep track of everything. Just 1, 2, and 3, nothing super creative. And this time I'm just going to do something different. I'm going to choose to eliminate my x's in 1 and 2. So to do that, if I multiply the top equation by -3, it would create a pair of opposites. There's my new equation, and if I just copy my second equation, and now I will stack and add. And let's see, when I do that, my x's are eliminated, and I get 7y minus 23z equals 5. So I need to eliminate the same letter in two other equations. So you could do 1 and 3, you could do 2 and 3. I'm going to choose 2 and 3. Actually, you know what? I think I'll do 1 and 3. It looks a little easier. So this time, if I multiply the top equation by 2, I would have opposites. So that would give me 4x minus 2y plus 12z equals -8. Recopy equation 3 exactly as I see it. Oh, and I just realized I didn't squeeze a z in there. Equals 9. And now I stack and add. So my x's disappear, and I have -4y plus 17z, my handwriting's a little sloppy there, equals 1. So now I create a new system out of my two new equations from 1 and 2. So that's this one here and this one here. I'm going to try to create opposites. So I'm going to multiply this one here by 4 to get rid of my y's. That would make a 28y, which means I need to multiply the bottom one by 7. So that's going to produce 28y when I distribute this 4. Minus 92z equals 20. And the bottom one would be -28y. 7 times 17 is 119, so plus 119z equals 7. And I'm going to stack and add. My y's are eliminated, and -92 plus 119 is 27z equals 27. Those numbers were getting ugly. For a second I thought, oops, not z. I thought maybe I had a mistake. Divide both sides by 27, and I get z equals 1. So my ordered triple xyz would have, there's my z. And now I just kind of work backwards. You're going to plug this in to a previous equation. So I'm just going to use this equation here, which would be -4y plus 17 times 1 equals 1. So I'd have -4y plus 17 equals 1. I'm going to subtract 17 from each side, which gives me -4y. Just going to give myself a little more space here. Equals -16. Divide both sides by -4, so y equals +4. So in my ordered triple, I've got my y, and now I need my x. So you're going to go back to one of your original equations. I'm just going to do the top equation, the 2x, equation 1 as I numbered it, minus y, which is now 4, plus 6 times 1 equals -4. And let's do the algebra. So this would be 2x minus 4 plus 6 would be +2. So 2x plus 2 equals -4. I need to subtract 2 from each side, gives me 2x equals -6, so x equals -3. And there's my ordered triple. I'm going to fill in -3. All right. Okay. This one ends up being a special case. So let's choose again to number our equations to keep track of stuff. And I like my y's. I'm going to choose to eliminate y in, let's do 1 and 2. So this gives me x, I'm going to multiply by 4, or -4. So -4x, here on the top one, minus 4y, minus 4z equals -12. Recopy the second one, 4x plus 4y plus 16. What am I doing? not 16, 4, I'm not changing anything, plus 4z equals 7. Now I stack and add. Eliminated, eliminated, eliminated. Awesome. So I have 0 on the left equals -5. Double check, make sure you didn't mess up, but this is a nonsensical statement. So this is a solution where there is none. There is no point where all 3 lines intersect. In our fourth example, again, if I number my equations, I'm going to choose to eliminate z, because I notice that they're all z or negative z. Looks like it'll be the least amount of work in 1 and 2, which really just means I can just stack and add because they're already opposites. All right, so that gives me 2x plus 2y equals 8. Now I'm going to eliminate z in 2 and 3. So I just recopied them because z is already opposites, and I stack and add. It gives me 4x plus 4y equals 16. Okay, now I'm going to use my new system. So I will multiply this one by -2 to create opposites with the x's, and that gives me -4x minus 4y equals -16. Recopy the other, and stack and add, and I believe I get a true statement. So this would be where there are infinitely many solutions. Now you will see, if you look in the textbook, where they get more detailed with ways of expressing your solutions, but for this course, it will be adequate if you just tell me that there are infinitely many solutions, but recognize there is a better way that we can even describe where those solutions fall in an XYZ coordinate plane. And now it's time for you to practice. It's really easy to watch me do a video and follow along, but you're not going to realize the questions you even have until you practice these problems. They can be tedious, but hopefully you find them weirdly rewarding like I do. Have an awesome day.